Okay, so welcome back, and now what we're going to do is we're going to use Newton's method to approximate the square root of 2. Okay, so we've used linear approximations to approximate square roots, like approximating the square root of 9.1, right? But in this case, what we want to do is we want to approximate the square root of 2, and this is how your calculator does it. So what we're going to do is we have to come up with a function that has a root at the square root of 2. Okay, right? So the square root of 2 is an irrational number, so it just keeps going on. Okay? So all we have to do is come up with a function that has a root at the square root of 2. So let's do x squared minus 2. Right? So the function x squared minus 2 has a root at positive 2. Now here's what we're going to do is we're going to use x0 equal to 2 as our first approximate. Okay? Our first approximation. So now we're going to do the iteration. So they want us to do the first 5 and see what we get. So again, we're going to have to use the calculator to store it in the calculator. And here we go. So f prime of x equals 2x. Okay? So now, if we want to do x1, we're going to do x0 minus f of x0 divided by f prime of x0, which is then going to be equal to what? 2 minus f of 2 over f prime of 2, which is then equal to what? This is going to be 2 minus, well, if I put 2 in here, I'm going to get 4 minus 2, which is 2. And if I put 2 in here, I get 4. So it's going to give me, what, 1.5. Okay, so that's my first one. Okay. So now let's do the next one. Okay, so now we can keep going like this, right? But let's see what happens here. If I go to, if I keep going in like manner, right? I'll get them all. But let's start over. And let's see something here. Let's do, let's define, let's use the formula x sub n equals x sub n minus 1 minus f of x sub n minus 1 divided by f prime of x sub n minus 1. Okay, so now, so we have x sub n minus 1 minus, now what happens here? We're going to get x squared of x sub n minus 1 minus 2, and then divided by 2 times x sub n minus 1. So now what I'm going to do is I'm going to simplify this. I'm going to get a common denominator, so I'm going to multiply the top and the bottom by 2x sub n minus 1. So that's going to give me 2 times x sub n minus 1 squared minus x squared n sub n minus 1 minus 2. So it's I'm subtracting off this, so this will be a plus. Okay, and then this is going to be all over 2 x sub n minus 1. And now what's going to happen is here I get 2x squared sub n minus 1 right here, and I've got minus 1 of them. So that's going to give me x squared, x sub n minus 1 squared, plus 2 over 2 times x sub n minus 1. And so I can use that. Okay. So what do I get? I got 1.5 for the first one, right? So I get x1 is 1.5. So let's see, using this, if I want to get x2, now all I have to do is just plug in 1.5. So let's do, it's going to be 1.5 squared plus 2 over 2 times 1.5. Okay, so this is going to be 2.25 plus 2 over 3. Okay, which is going to be 4.25 over 3, which gives us what? 1.416. 1.416. Okay, so in other words, it's that. And now, x3, now I'm going to plug it into the same equation, so it's going to be 1.416 with a bar squared plus 2 over 2 times 1.416 with a bar over the 6. Again, you could put, again, save this in your calculator so it goes up more digits. And if you calculate that, you get 1.4142 15686. Okay? And then if you do it again, x4 is going to be approximately 1.4142 3562. So we get 1.41421 3562. And then for x5, you get the same numbers. So what this tells you is, as far as the calculator goes, anything after x4 is going to give you the same 9 decimal places. Okay? And so it's accurate up to 9 decimal places after that. Okay? So it's unlikely that anything will change after x4. And that's how you approximate the square root of 2 using Newton's method. Have a great day.